Hello everyone, welcome to Chemizon Complete Chemistry. So in today's video we are going to solve question 36 which is based on Beckmann fragmentation. So from question 36 onwards, from 1 to 35 it was 1 mark each. All the questions were of 1 mark. Now from 36 onwards questions are of 2 marks. Okay, so this is Beckmann fragmentation. So let us first understand the question that is given to us. So this is a reactant that is given. It is a ketone. There are 4 steps that are given in the reaction, and we have to identify what? We have to identify product P. Okay, P is what we have to identify. So let us start solving this step by step. So first, what is given to us is ketone. A ketone. Now first they have given 2 equivalents of NaH. Now you have to understand what is NaH, sodium hydride. Na is plus, H is minus. Now you must know that this is a very good base. It is a strong base. Okay, H minus, it can easily abstract a proton and it can form what? Stable hydrogen molecule. That is why H minus is a very strong base. So NaH is a base. So what you have to find out is, in this molecule you have to find out the acidic proton. Now what is meaning of an acidic proton? After removal of that H plus ion, you will get a negative charge. Okay, you will get a negative charge, and that negative charge should be stable. Now out of these 3 negative charges, which is going to be most stable, that we have to identify. Now if you see this first one, this negative charge is stabilized by resonance with the pi electrons of the benzene ring. Okay, this second negative charge, if you see, it is only stabilized by resonance with the carbonyl group. So this is less acidic as compared to benzene ring. There will be more resonance structure. More the number of resonance structure, more is the stability. So this will be less stable. Which will be most stable is this third one, a third carbocation. Why? Because this is stabilized by carbonyl group, as well as it can be stabilized by the pi electrons of the benzene ring like this. So the third one is going to be the most stable carbon ion, and that is going to be the most stable, that is going to be the most acidic proton. So these 2 hydrogens are most acidic. So 2 equivalents is given, right? So what we will do, first we will use the 1 equivalent, H minus 1 equivalent. Okay, I will abstract this proton. Okay, I'll get the conjugate base. Let me draw the conjugate base. C double bond O, lone pair, that is negative charge. And then this negative charge is going to react with, next is methyl iodide. Okay, 1 equivalent we are using. So now there will be alkylation. Okay, alkylation at the alpha carbon. Yes, it will attack CH3 and I minus will go away as a good leaving group. So what we will get is benzene, C double bond O, and here we have hydrogen and CH3. Now what is going to happen is, this entire step is going to repeat. 2 equivalent of base is given, right? And there is one more acidic proton. So what we can do is, we can take another equivalent of H minus, attack this, get the carbon ion. Okay, the conjugate base is formed. Negative charge, 1 methyl is already there. C double bond O. Now this is going to react with methyl iodide. Another equivalent of methyl iodide. This will attack. I minus will go away as a good leaving group. So what I get is, at the alpha position, now there are 2 alkylated groups, that is 2 methyl groups are present. Okay, this was the A and B steps. Now what is the next reagent is NH2OH. NH2OH, that is hydroxyl amine. OH is hydroxyl, NH2 is amine. So this is hydroxyl amine dot HCl. So what will happen? The next step is, now NH2OH Okay, what I can do, hydroxylamine. Now there will be loss of water molecule. Okay, oxygen and H2. H2O is lost. Okay, what I will get is compound called as oxime. Let me draw here at the top. What I will get is a oxime. Benzene ring. Here there are two methyl groups. Double bond NOH. Okay. Now this is oxime. C double bond NOH. This functional group is called as oxime. Okay, so we have got oxime. Now HCl is present in the medium. So what will happen? This OH will be protonated like this. So the alcohol is protonated. Oxygen will get the positive charge. Now what is the next step is, generally what we do Beckmann rearrangement. Okay, in rearrangement what we do, this R group will migrate to nitrogen and this will move here, and then there will be tautomerism to form amide. But in Beckmann rearrangement, what you have to identify is whether there is a possibility of formation of a stable carbocation. So now suppose if I break this bond like this, okay, here I will get a positive charge, and you can see this is a tertiary carbocation, it is stable. Okay, so instead of migration, what happens is the entire bond breaks. The bond between this carbon and the carbon forming double bond breaks, and the electrons are moved at this carbon. Now this carbon will form a triple bond and water will go away as a leaving group. Last step is PCl5. PCl5 is a what? Dehydrating agent. It is a good dehydrating. Dehydrating agent means removal of water, or agent that can ease the removal of water, loss of water molecule. Okay, let us see the mechanism again. What did I do? First step is, we'll break this bond like this. Carbon carbon double bond will become carbon carbon triple bond, and this water molecule will go away as a good leaving group. What we get is, here I have carbocation formation, and this is a carbon. Now double bond will become triple bond. This water molecule will go away as a good leaving group. Okay, so this is the product that I've got. Will it stop here? No. Okay, what will happen is there will be elimination reaction. Okay, there will be elimination reaction and we'll get alkene. What is going to be the final product? Okay, any water or any water can act as a base and it can remove this H plus ion. What I will get is benzene ring. There are how many carbon? 1, 2, 1, 2. Then there is cyanide. Here we have formation of CH3 double bond CH2. Alkene is formed. So this is the final product. Okay, so let us see the options. So 2 carbon, then cyanide and double bond and then methyl. So the correct answer is option A. I hope you have understood the solution. Thank you.